In 6.1, you did plus and minus equations. In 6.2, you did multiplication division. So 6.3 is going to have multi-step inequalities. Maybe you'll have to combine like terms. Maybe you'll have to use the distributive property, but there's all kinds of things they're throwing at you. So in the text, they started with a word problem. And this equation right here that you're looking at is all about converting from Fahrenheit degrees to Celsius degrees. So that's where this is coming from. And there's a little bit of an explanation in it, but this is one of those types of problems in a textbook where you kind of just want to go straight to the formula and go from there. So find the body temperature in degrees Celsius of a camel that has had no water by noon. And so they tell you that it's 104 degrees Fahrenheit. It's going to be more than that. So this conversion is going to give it to you in Celsius. And if I have a word problem like this, I will rewrite the equation that they give me. 9/5 capital C, where C is the variable, plus 32 is greater than 104. Now, just like when you would solve a old two-step equation, you're just going to subtract that 32 from both sides, which leaves you with 9/5 C is greater than, what do I have here, 72? Now, depending on how you want to write this, it's probably a little bit nicer to be like times 5/9 times 5/9, and that's going to get rid of everything but C on the left side. No need to change the direction of the inequality. And then 9 and 72 cancel out to give you 8, and 8 times 5 will give you 40 degrees Celsius. So find the body temperature of the camel in degrees Celsius. So you'd say the temperature, we can put a little summarizing sentence here, is greater than 40 degrees, and then this is important, Celsius. If you need a moment with that, take it. Let's make this an OYO problem, so pause the video, and then I'll put an answer up in about 5 seconds. Well, the most challenging part of this problem is to come up with an equation. So if you're thinking, well, 400 minutes, then I'm going to say, well, x is the variable that represents minutes. So 400 times x will give me the total cost for all the minutes that I end up using. That price also would include $3.50 because that's just being taxed on. That would have nothing to do with the variable. If the competition charges $43.50, well, here's the deal. It's got to be less than what the competition charges. So after 400 minutes and the tax, that would all be less than the competition's $43.50. And then if you have it, solving for it's not so crazy. So I found x is less than 1/10, in which case, we're thinking 10 cents. So ABC charges 10 cents per minute. And that's how I might write that. ABC charges 10 cents with a fraction per minute. If you want to talk about this one, let me know and we will spend more time on it. The next problems have all the real-world context stripped away from it, and they say, well, we're going to do inequalities that involve a negative coefficient. So these are just going to be multi-step, and then if we've got a negative coefficient, chances are we're going to have to divide or multiply by a negative, and then as you know, that means we're going to change the directions of the sign. So I got negative 7b plus 19 is less than negative 16. Now, this is not why we changed the sign. It's more about this guy later on. But before we get to that, I need to get as close as possible to having b all by itself. And the earliest step, just like when you solved multi-step equations and two-step equations, you would have to get that 19 away. So I'm subtracting 19 from both sides, and I'm going to get negative 35 on the right. Now, the opposite of multiplication is division, so we're going to divide by negative 7. Notice that I'm talking quick because this is pretty procedural by now. You have these habits in place. And if I have to divide by a negative, I also have to flip the sign and box it. Now, it does not say to graph this, but if I want to be thorough, I should. So here's 0, here's 5, and b is going to be greater than, but not equal to it. So I'm going to have an open circle. So that means that it can be 6 or 1 trillion. It does not matter. Now let's check this in our original problem. Let's plug in 5. negative 7 times 5 is negative 35, plus 19 is negative 16. And I can type that all into a calculator if I need to. So I'm cool with getting the pivotal point there accurate. Now let's try a billion. If I try to plug in 1 million, 1 billion, whatever, this would be like a very, very negative number, which is definitely less than that negative number. So I feel good about the answer B greater than 5. I think that makes problem 2 straightforward enough, so let's make this an on-your-own problem and check the work in a few seconds. Pause the video. First and foremost, if you felt like it, a little tip that I would give you is that you could write it in opposite order if you like to see the variable on the left. Sometimes that's a little bit nicer on these, but make sure that you would change the direction of the sign. I chose not to do it that way because I figured you might not do it that way. So I subtracted 10 from both sides in this step, and then I divided by a negative. And when I divided by a negative, I had to change the direction of the sign in this step. So let me fix that. And and that threw off everything I did, so hopefully that's fine for you. So what I was saying was, when I divided by a negative, that ends up making me change the direction of the inequality in this step. And then as a final step, if I had negative 13 halves is less than or equal to W, it's better for me to say W is greater than or equal. So here I changed the sign again, but that's only because of the way I said it. It's instead of being like cool is Mike, I would say Mike is cool. So if I reverse the direction in which I say something, I have to fix that. Now, when we plot a number line with a fraction, I see 13 halves as being 6.5. And I got as accurate as I could be while using this iPad. Yours should look definitely that good. But I had to plot 0 to negative 10 to make this look well. And let's talk about how we could check this. Well, you know, if I checked it with a decimal, I would use my calculator. But I'm going to see this as 2 times a negative 13 halves. Well, the 2's go away, and I just have negative 13. So then what happens is I don't subtract that 13. I add that 13. And 10 and 13 does give me 23. So that gives me that pivot point. And now I have two options. I could check something with 0, or I could check like just a really big number in my head. I'll talk about it both ways, and you can decide which one you like more. 10 minus 0 is 10, and 10 is definitely less than 23. I think that was easy to figure out. Now let's say I did 10 minus a very, 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 very large number. Then I would have a very negative number, and then that negative deal would definitely be less than 23. So either way I do it, I'm good. Just like this problem, make problem 3 OYO, and I'll put the solution up in just a moment. So we actually landed on a integer this time, which made it nicer. And if I plug in negative 8 times negative 4, I get positive 32. Plus 11 is 43, so there's the switch point. And then if this one I plugged in 0, then this term would totally drop out, and 43 would be greater than 11, or 11 would be less than 43. That takes care of it for this video.